The Sun is a fascinating and complex star at the center of our solar system, and its presence is crucial for life on Earth. Here are some key facts about the Sun. 1. Basic characteristics. Type of star. The Sun is a G-type main sequence star, G dwarf, in the Hertzsprung-Russell diagram. It is a yellow dwarf star, which means it is a medium-sized star. Size. The Sun's diameter is about 1.39 million kilometers, 864,000 miles, roughly 109 times that of Earth. Its volume could fit around 1.3 million Earths inside it. Mass. The Sun's mass is about 1.989 times 10 to the 30 kilograms, which is approximately 330,000 times that of Earth, making up about 99.86% of the total mass of the solar system. Distance from Earth. The Sun is, on average, about 93 million miles, 150 million kilometers, away from Earth. This distance is called an astronomical unit, O. 2. Composition. The Sun is made primarily of hydrogen, about 74%, and helium, about 24%. The remaining 2% consists of heavier elements such as oxygen, carbon, neon, and iron. 3. Core and energy production. Nuclear fusion. The Sun's energy comes from nuclear fusion, a process that occurs in its core. At temperatures of around 15 million degrees Celsius, 27 million degrees Fahrenheit, hydrogen atoms fuse to form helium, releasing an immense amount of energy in the form of light and heat. Energy output. The Sun emits about 3.8 times 10 to the 26 watts of energy. This energy travels through space and provides heat and light to our solar system. 4. Structure. The Sun has several layers. Core, the innermost layer where nuclear fusion occurs. Radiative zone, the layer surrounding the core, where energy is transferred outward through radiation. It takes thousands of years for energy to travel through this zone. Convective zone, above the radiative zone, hot plasma rises and cools in a convection process. Photosphere, the visible surface of the Sun, which has a temperature of about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. Chromosphere, a thin, reddish layer above the photosphere. Corona, the Sun's outer atmosphere, which is much hotter than the surface, reaching temperatures of 1 to 3 million degrees Celsius, 1.8 to 5.4 million degrees Fahrenheit. 5. Solar activity. Sunspots. These are temporary, cooler regions on the Sun's surface caused by magnetic activity. They appear darker than the surrounding areas. Solar flares. Sudden bursts of energy and radiation from the Sun's surface that can affect space weather and disrupt communication systems on Earth. Solar wind. A stream of charged particles, mainly electrons and protons, constantly flowing outward from the Sun. This can interact with Earth's magnetic field, creating phenomena like auroras, northern and southern lights. 6. Sun's life cycle. The Sun is about 4.6 billion years old and is currently in the middle of its life cycle as a stable main sequence star. Future. In about 5 billion years, the Sun will exhaust its hydrogen fuel. It will expand into a red giant, possibly engulfing the inner planets, including Earth. After shedding its outer layers, the Sun will shrink into a white dwarf, cooling down over billions of years. 7. Impact on Earth. The Sun's energy supports life on Earth by providing warmth and light. Without the Sun, Earth would be too cold to sustain liquid water or life as we know it. The Sun's radiation can also affect human health, potentially causing sunburns and increasing the risk of skin cancer if one is overexposed to ultraviolet radiation. 8. Sun and time. The Earth orbits the Sun once every year, a period that defines the length of a year. The Sun's apparent motion across the sky defines the passage of days and seasons. 9. Solar system formation. The Sun formed from a cloud of gas and dust in space about 4.6 billion years ago. As gravity caused this material to collapse, the core heated up and initiated nuclear fusion, forming the Sun. 10. Solar system influence. The Sun's gravity is responsible for the orbits of all the planets, moons, asteroids, comets, and other objects in the solar system. Its magnetic field also affects the solar system's space weather environment. 11. Exploration of the Sun. Spacecraft such as NASA's Parker Solar Probe, launched in 2018, have been sent to study the Sun up close. The probe will come closer to the Sun than any previous spacecraft, helping scientists better understand solar phenomena. The Sun, while appearing static and unchanging, is a dynamic and ever-changing star with processes that influence the entire solar system. Understanding it is crucial for both space exploration and life